Welcome back to the film room, everyone. Grab a seat. Today we are breaking down the game tape for literally one of the most high-stakes matchups in your entire Cambridge AS and A-level math syllabus. We're talking differentiation, specifically stationary points and their nature. Look, if you're looking to completely conquer paper 9709, you've got to view this like a championship game. We are going to treat the examiners like the opposing defense, we'll analyze their play patterns, and we're going to build a playbook that guarantees maximum marks. So, strap in. This explainer is your direct path to the absolute top of the league table.
Now check out this quote right here. This is directly from a senior Cambridge examiner. The difference between a B and an A star often comes down to this. Now, what are they talking about? They're talking specifically about multi-stage analysis and differentiation. You see, mastering stationary points, well, it isn't just about knowing your basic derivatives, right? It's about executing a complex string of logical steps under immense pressure. It is literally your ticket to an A star. If you can master this tape we're looking at today, you completely control the game.
All right, so here is our tactical game plan for today's explainer. First, scouting the examiner, then the method mark strategy. After that, the execution playbook, followed by avoiding unforced errors, and finally, the winning sequence. Let's get right into it.
Kicking things off with step 1, scouting the examiner and their defensive strategies.
Okay, to beat the defense, you absolutely have to know how they set up their benchmarks. In Cambridge math, the examiners prioritize analytical depth over superficial breadth. What does that mean? Well, they're looking for logical, structured reasoning, not just a shallow understanding of a bunch of different concepts. On the game tape today, I actually want you to imagine two specific candidates we're reviewing. Let's call them Alex and Sam. Now, Alex plays a heavy defense, super solid on the basics, but kind of lacks that open-ended analytical speed. Sam, on the other hand, is a fast attacker. Sam jumps straight to conclusions but gets super sloppy on the execution. Here's the truth. Neither of these approaches wins the championship because they both lack the structured depth the examiner is actively demanding.
So you're probably wondering, how do we actually build that depth? Well, principal examiner reports give us the ultimate cheat code. Candidates who reference cross-topic connections score significantly higher. Period. You absolutely must build precise definitions. You need to establish causal relationships, like linking the sign of the second derivative directly to the nature of the stationary point. And you've got to forge connections with other syllabus areas like coordinate geometry or quadratics. Honestly, it's like a giant puzzle. Putting those pieces together, that is exactly how you outmaneuver the defense.
Moving right along to section 2, the method mark strategy, or as I like to call it, your guaranteed yardage.
I want you to think of this as your guaranteed yardage on the field. You don't always need a massive 60-yard touchdown pass to win the game, right? Sometimes you just need to keep moving the chains. Enter the method marks. These are points awarded for demonstrating the correct mathematical process and clear working, regardless of whether your final arithmetic calculation is perfectly accurate. This is absolutely crucial to understand. You get rewarded for the process. You get points for the cognitive reasoning and the analytical framework you apply. It's really all about showing the examiner you know the play, even if you stumble slightly on that final step.
Now, what's really interesting about this is how top-tier players secure points compared to amateurs. Let's look back at our players, Alex and Sam. Sam makes the classic rookie mistake here. Sam does the differentiation entirely in their head, jumps straight to the final coordinates, and just loses all the process points when a minus sign inevitably gets dropped. It's a total turnover. But Alex uses the veteran strategy. Alex writes out the derivative, explicitly states set dy over dx equal to 0 for stationary points, solves it step by step, and then tests the nature. Even if Alex makes a tiny arithmetic error, they secure almost all the method marks. That, my friends, is how veterans play the game.
All right, let's open up section 3, the execution playbook, featuring the DESEP play.
Okay, time out real quick. Before we drop this play, if you want to stay at the absolute top of the league table this exam season, make sure you subscribe to Ace the Exams and enable all notifications right now. Okay, whistle blown, we're back in. So how do we guarantee we play like a veteran every single time? We use DESEP. This is your ultimate go-to offensive play. Step 1, deconstruct the question. Ask yourself, what is it actually asking me to do? Step 2, extract relevant data, like the exact equation of the curve. Step 3, select your analytical framework. In this specific case, differentiation and the second derivative test. Step 4, execute with clear notation. Seriously, do not mix up y with dy dx. It's a total trap. And finally, step 5, present with correct terminology. The source material emphasizes over and over that presentation follows strict conventions. We're talking proper headings and clear annotation. You have to tell the examiner exactly what you are doing at each and every step.
Now that execute phase, it requires incredible depth, especially when the question throws an intricate evaluation prompt at you, like asking for a critical comparative analysis of two different stationary points or curves. You can't just list numbers on the page and hope for the best. No way. You need to identify similarities and differences. You need to use comparative connectives, support your mathematical comparisons with actual, calculated evidence, and then draw clear conclusions. Honestly, it's almost like writing a mini essay, but with numbers. You are literally justifying your analytical decisions to the referee.
Let's transition into Section 4, Avoiding Unforced Errors, or as I call them, examiner warnings.
All right, halftime. Grab some water because we really need to talk about the defensive traps the examiners lay out for you. Let's run a quick interactive drill. Take a look at this. What do you think is the absolute #1 mistake costing candidates the A-star in these stationary point problems? Seriously, I want you to mentally lock in your answer right now. Got it? Are you thinking it's bad algebra? Maybe forgetting the chain rule? Let's see.
Okay, here is the big reveal straight from the principal examiner reports. Number 1, using the wrong approach for the wrong context. Like, trying to use the quadratic formula on a cubic derivative without factorizing it first. Just the bad play. Number 2, forgetting to check format and presentation. And number 3, the absolute killer, providing generic answers that are not specific to the context given. Let's run a quick spot the penalty drill on our fast attacker Sam. Sam writes on their paper, the point is a maximum because the derivative is negative. Bam! Penalty. Flag on the play. Which derivative? At what value? It's way too generic.
So, the crucial takeaway here is this massive examiner alert. Always link every mathematical point back to the specific given scenario. If the question is about, say, the maximum volume of a box, don't just write x equals 5 as a maximum and move on. No, you say the volume of the box is maximized when x equals 5 centimeters, because the second derivative, d2v/dx squared, is negative at this value. Context is king here, guys. Generic answers, they're an immediate red card.
Now, let's see how all this builds into evaluative thinking. Top-scoring candidates, the real champions of this league, they don't just turn the crank on the algebra like a robot. They evaluate the quality of their mathematical evidence. They actively spot limitations. For example, if you're solving a problem and you find two stationary points, but one of them gives a negative length for a physical object, well, you must explicitly state on the paper that you are rejecting that assumption, because obviously a physical length has to be positive. Considering these alternative interpretations and actually justifying your final decision, man, that is exactly what separates the A-star players from the rest of the pack.
And that brings us to our final section, number 5, the winning sequence for game day execution.
All right, team, listen up. We are officially in the fourth quarter. It's time for the final drive down the field. Systematic processing has to follow a standardized sequence. For your standard 8 to 10 mark differentiation problem, your mental timeline needs to look exactly like this. Minute 1, identify the key elements and completely deconstruct the prompt. By minute 3, you're applying the relevant principles, meaning you differentiate the function. By minute 6, you are executing the analysis. You're setting it to 0 and finding the x and y coordinates with perfectly clear working. And finally, minute 8 is reserved for verifying the results using the second derivative and formatting your final statement to perfectly match the context. I promise you, stick to this clock and you will never run out of time on exam day. Well, we've officially reviewed the tape, and you now have the ultimate game day preparation checklist. The only question left is, will you execute the playbook, or are you going to fall for the examiner's traps? Do not let the defense dictate your grade. I want you to apply this DESEP strategy to your past papers starting today. Drop a comment below right now. What is your target grade, and what play are you going to run first to get it? Don't forget to hit that subscribe button, ring the notification bell for Ace the Exams, and keep grinding. I'll see you in the next explainer.